Hey, welcome back to Fat Mama Physics. So hopefully you can hear me amongst all this noise in this lab. And I don't have my mic here, so the volume's gonna suffer a little bit. Anyhow, we have a video on this part 2 of your mass versus acceleration lab. This part of the video, I am going to show you how to use the Pasco software that should be installed on your computer already. So here on your screen, on my screen, you see a graph which I generated from the motion associated with the moving of the cart. I'll show you a live demonstration in a moment, but I'm just going to give you kind of the final product, what you should expect to see afterwards, okay?
Just to quickly interject, how to set up what the Pasco Capstone interface is. First, let's start over here. You have a Pasco Capstone icon on your desktop. It looks like a little pyramid, so you click on it. Then you will see this page over here. There's many options. You want the one that says sensor data, so you're going to get data received from a sensor, which then Pasco is going to plot a graph. Then you'll have something that looks like this. Nothing is plugged in right now, so that's why you see that. But one thing you want to be able to toggle between is this red pin bar, which you click it allows you to see the whole graph, as well as the bunch of tools here that is very hard for you to see. But hopefully my cursor can magnify it. And select measurement is down here, which then it will automatically populate once you start collecting data from your sensor. And now on with the rest of the experiment.
So I have in front of me, I have a graph. I have a position versus time graph. And it's very nice because you can switch between position time graph to velocity and acceleration time graph, etc. So more on that later. Notice a few other things when I have things set up here is assuming that your motion tracker is attached through USB link to your computer, you should see this bottom right here. It should say motion sensor, not common, I forgot the other name. It should say motion sensor, and I've adjusted the reading frame to be 50 hertz, so 50 times a second. You can make it higher, it's not really necessary, and it kind of gets a little wonky if you have too many, if your frame rate is too high. So 50 hertz is pretty good. Notice here, this is the part of the graph that where my object was moving, so I've highlighted it over there. I'm not sure if a linear fit would have been very nice here because it looks like it's a little curvy. More on this one in a moment. Okay, so what I'm going to do now is I'm going to set up a live demonstration where I'm going to film the my motion and also have what it would read here on this graph. Okay, so let's give me a moment here. Okay, so this is pretty much the old graph that I have. So I would say after every trial you should record your data in case it gets lost in the computer. What I'm just showing you is kind of the basics on how you can use your Pasco software. There's probably a lot of things I don't know about the software, and which after you playing with it a few times might discover things I don't know. So I think when I press record, it's going to actually record over this current graph. I think there's a way to save it, but if you find a way, great. But I just want to show you what the data that you should be getting. Okay, that's the purpose of this video. I'm going to click here and it says record. I would actually press this before I start the data collection because you just have all this time lag in between which you can just skip, right? So I'm going to press record here. And you might notice that you might hear a ticking sound, and I'm going to go right over to my experiment. So I have my track set up. I'm going to have my mass hanging on the other side. Okay, and then I'm going to let go. Don't forget to hold your cart at the end. I have no mass on top of my cart, so this is just a dry run. Ready, set, go. Okay, I'm going to actually do that again because I actually touched the string, which is no good. Ready, set, go. Okay, that's better. Very gentle. I'm going to flip the cart on the bottom side like this so it doesn't roll around. Okay, and then I am going to stop this recording. Okay, So now you see a lot of things here. And the reason why I like to start on a position time graph is because it shows you very well, it's very clear where the motion started, where the motion ended. You can see that this first part here is where I screwed up. This is the second part of this is the part I want, okay? So you can scroll in and out using your scrolly button, and you actually click on the graph just to move it around. So I'm just going to scroll in to the part that I want, which is this part. And I don't have a very smart way of doing this, but what I want to do now is, because this is the acceleration time graph, you can kind of see how this graph is not exactly straight. So it doesn't have a constant velocity. Well, it's accelerating, of course. So what I'm going to do is I'm going to go change up this graph to make it a velocity time graph. So I click here on the side, position, and then go down. I'm going to click velocity time graph. Before that, I'm going to keep note that the motion here started, the motion that I want started at 32 seconds. And yeah, there's no smart way of tracking that. So I'm going to just go to velocity. 32 seconds is roughly about here. So I'm going to go move in. And you can kind of see this little hump. This is the little hump that you want, okay? So you can see that the object is speeding up here. It's gaining velocity. You might be wondering, well, if you want the acceleration, why won't you just use an acceleration time graph? Well, if I do an acceleration time graph, there's going to be too much variation in the data for you to actually pick the correct amount of points. If I use the velocity time graph, I look at the entire motion because I know my object is going to accelerate, it should accelerate at the same rate down the cart. If I use a velocity time graph and just grab the slope, I am using all of those data points. So it gives me a better picture of what the acceleration is. So now what do I do now after I see this graph over here? What I can do is I'm going to go up here. And if you don't see the sidebar, maybe you have to click this red button here, which is the puts it out like this. You click this red pin bar to kind of reveal the side, and as well as all of these tools up here. The tool that we want is this little, looks like a highlighter. It's got 3 dots and this highlighter piece. I'm going to click it, and notice this box shows up. This box is essentially the dots that I want to highlight. I can drag however many dots I want to include. I like the straight line here. It looks pretty much like this is the part where it accelerated at a constant rate. So here it already shows me the slope, but let's say it doesn't. Then what you can do is, if I hover over here onto the top, is you can see that there are a few options, and the one that you want is this one here. It says curve fit. I click on curve fit, and then this allows me to choose what's the best model for my graph. Of course, for us it's a linear fit because the slope on a velocity time graph gives us the acceleration. So I'm going to click on that, and I actually had it on. So if I click it again, it turns it off. So if I click this again, I turn it on again. And I can reselect the dots here, my data points, to give me a nice picture. So here my slope reads 1.52 meters per, of course, you would have to figure this out graphically. That's your velocity divided by time, meters per second squared. For your lab, notice that in this acceleration piece, it tells you an uncertainty that's associated with this particular graph. In fact, for us, you will be doing the same trial, which is however mass you put on your cart. You're going to do that same trial for about 3 to 4 times, okay? So that means you're going to have at least 3 different acceleration values that you need to take the average of, which means you're not going to need this uncertainty here. Actually, you could include it in your data recording. It would just be that in the end, when you actually do your calculations, you're not going to need it because you're going to get the uncertainty of your acceleration for the whole, as you calculate all your repeated trials. So you're going to have one acceleration for one mass that you have, or one mass interval that you have. Okay. So for example, I did this experiment with no mass on my cart. This could be one of the trials. This trial, I'm going to repeat it 3 to 4 times, and I'm going to take the average of these 3 to 4 acceleration values to use as the acceleration for the mass of my cart that I'm using in this particular experiment, in this trial. As you have a repeated number of trials, you will then be able to find the uncertainty from these repeated trials, max minus min, all of that divided by 2. So you're not going to need this uncertainty here. You can record it, it's up to you, it's optional. Okay? Just in case you lose all your trials, I would just record your acceleration value before you move on to the next one. I believe there's a way on this side of your software for you to be able to save all these points. You can go ahead and figure this one out. But really, the purpose of this video was to show you how to find the acceleration from this particular lab. So I thank you for watching. Hopefully this is enough to get you started and recording your data for your lab. Don't forget, you want to record the mass, total mass of your whole system for every trial, as well as the acceleration. And don't forget to do your repeated trials. I wish you good luck. Thank you for watching. Fan Mama Physics signing out.